And welcome back. We're going to continue talking about the process of research by discussing some different forms of study designs. So, if you remember, again, we have covered steps 1 through 4 in the first several sections of this research process material. So today we're going to be talking about step 5, where we figure out how we're going to test our hypothesis that we've made. So, this is a good moment to pause and review for a second. So at this point, we've developed a research question. We've translated into these operational definitions into forms that we can actually work with. We know what people we're interested in understanding, our population, and we've found that we have at least the ability to draw a sample from it. Maybe we already have a group of people lined up. Now we have to figure out how we're going to use that study design, that framework, to get the data that we want on our research question. So, the most basic dimension on which different research designs differ has to do with what form or what category of design they fall into along this dimension of descriptive designs, correlational designs, and experimental designs. Now, each one of those designs is structured a little differently, and they each differ in terms of what information they provide and what you can do with that information statistically. In this material, we're going to focus on the first two designs that are a little bit simpler. Experiments are a bit more complex, so we're going to, again, spend a little extra time focusing on them in the next section of the lecture. So, descriptive designs are the single simplest form of research design. They give you the least amount of information, but they're often also the easiest to do, so it's kind of trade-offs there. So, right like it says in the name, a descriptive design is intended to describe variables, basically just to identify specific patterns of scores that we see kind of naturally in whatever population we're interested in. So, we use a sample, but we measure people's thinking, we measure their behavior, their emotions, whatever we're interested in, but we're just interested in summarizing it. We're not looking at relationships between variables, we're not looking at what causes changes in different variables, we're just getting a very basic kind of high-level look at how this variable kind of looks at the population level. So we don't manipulate anything. There's no independent variable or dependent variable. And if you don't remember what those are, good time to go back to section 2 and review IVs and DVs. But we don't manipulate or alter anything. We just measure stuff. And again, we're not even looking at relationships between variables. So an example of a descriptive design, a clinician might want to ask what proportion of the population is clinically depressed. And at the end of this, she's just going to have a number, a percentage. So it doesn't really tell her anything about what relates to clinical depression, what causes it, how to change it. Just gives a very basic description of how this stuff looks at the population level, how common this disorder is. A developmental psychologist might be interested in the average age of people's first sexual experience. Again, probably release some surveys, ask some folks some questions about it. Maybe they'll even tell the truth. But either way, at the end of this, he's going to have essentially a number, an average age of first sexual experience. It's not going to tell him anything about what that's related to, what other variables might be relevant in terms of what makes that number higher or lower. It's definitely not going to tell him anything about what might cause changes in age of first sexual experience. It's just a description, just a very, very basic piece of information, just what's the number, what's the average. Correlational designs go a bit further. Correlational designs give us all the information that a descriptive design might give us, but they add this extra element of evaluating the relationship between two variables or sometimes more. So here we're measuring multiple variables and we're seeing, do they tend to move in the same directions at the same time? Is there a consistent link between those variables? And if there is, what direction does it fall in? We're still not manipulating anything. We're just measuring stuff as it naturally exists. We're not directly changing anything. So there's no IV or DV, even though sometimes people interpret correlations in that way, which we'll talk about in a minute. The big advantages of correlational designs is that we can predict things. If I know how two variables are correlated and I know a score on the other variable, but I don't know the score on the second, perhaps because I just don't know it yet, perhaps because it hasn't happened, it's in the future, I can predict with some accuracy what a person's score on that second variable will be. So if you know the link between the relationship between two variables, you know someone's score on one of those, you can predict their score on the other. What we can't do, though, is determine cause and effect. We can determine the relationship between variables, but not which one causes the other. So, for example, that same clinician might do a follow-up study where she says, hey, is there any sort of relationship between people's IQ and their clinical depression? Maybe people who have higher IQs are more prone to depression. If she, say, found that, that would tell her there's a link there. She could predict people's depression level from their IQ or vice versa, but she wouldn't know that IQ causes depression. We don't necessarily know that one causes the other, but it would give us a little more depth, a little more nuance. What is that variable of clinical depression related to? What seems to be relevant to it? Our developmental psychologist might ask, is there a relationship between people's exposure to popular media and the age of their earliest sexual experience? Again, if he found a pattern there, he would be able to say those variables are related. He would be able to predict scores on one variable if he had scores on the other, but he cannot say that, say, media exposure is causing changes in earliest sexual experience. So a couple more terms in correlations. We have different descriptions for different directions of correlation. So what's called a negative correlation occurs when one variable increases, scores on the other variable tends to drop, and vice versa. So people that score high on one variable tend to score low on the other, and vice versa. They move in opposite directions. Some common examples of negative correlations, your age and your life expectancy. Unfortunately, the higher your age is, the fewer years you tend to have left, so the lower your life expectancy, your remaining life expectancy tends to be. The younger you are, the higher your life expectancy tends to be. Depression level and health, again, people who are more depressed tend to be in poorer health. People in better health tend to be less depressed. It doesn't mean one of them causes the other, but it does mean that they are linked. Positive correlations move in the opposite direction. People that score high on one variable tend to also score high on the other. People that score low on one variable tend to score low on the other. I'm doing my level best to keep these hands in the frame here. So basically the two variables move in the same direction. So for example, people's height is positively correlated with their weight. People who are taller tend to weigh more. People who are shorter tend to weigh less. There's just less person there. There are individual exceptions, but in general, that's the trend. Your SAT or ACT scores and your college grades. Part of the reason they're emphasized is people that score higher on those tests tend to have better college grades. People that score lower on those tests tend to have lower college grades. Certainly not that one is causing the other, but perhaps they're related to the same sort of idea, the same sort of underlying variable. Again, correlation does not equal causation. You should have had this hammered in your head in previous courses, but if you haven't, I'm here to tell you, just because two things are correlated does not mean that one of them causes the other. Here's the thing. Correlations oftentimes do represent causal relationships, but they don't give us enough information to confirm it. There are multiple different cause and effect patterns that are equally consistent with any correlation. One of the biggest mistakes that people tend to make in interpreting and describing statistics is they take correlational results and they interpret them as representing cause and effect. We really want to read causality into correlations, but we really just don't know. Correlations do not give us enough information to confirm that. So I'll give you an example. Every so often a study comes out and they measure college students, they measure how much alcohol they consume in a week, and they measure their GPA, and see if you can figure out what type of correlation that would be. Is a negative correlation. People that consume more alcohol have lower grades. People that have better grades tend to consume less alcohol. Now, that's a correlation. Think about how alcohol consumption could cause changes in college grades. Well, it's easy. You're out partying, you're not your best, you're not thinking clearly the next day, your grades tend to suffer. You don't study as much. You drink a little less, you have more free time, and your grades tend to go up. So that's possible. Now think about how college grades could cause changes in alcohol consumption. People get bad grades, and then they start drinking a little bit more to kind of avoid it, or vice versa. People with good grades maybe feel a little bit better about things overall, and they don't just go out and they don't binge drink as much. Or it's possible that neither one of them is directly causing each other, and there's something else that's driving both of them. For example, maybe people who are just naturally more impulsive. They tend to, think in terms of the short term. They don't plan ahead very much. They might tend to party a little more, drink a little more heavily, and be poor at organizing their studying or planning ahead for big assignments. So the first one could cause the second one could cause the first one, or neither one of them is causing each other. The point is, if all you have is the correlation, you don't know which one of those is the case. It could be any of them. So beware of interpreting correlation as causation. We'll talk more about that a little later on. But we're going to close things off for now, and then we are going to continue by talking about our third research design, experiments. See you then.